guys did the guided practice. It says to name all sets of numbers to which each real number belongs. You look at the number, and I see that it's a 0.05, 05, 05, 05. It keeps repeating. I've just learned this lesson, so I don't remember exactly what it's going to be. So I'm going to go back to my chart. We said it was a repeating decimal. If I look in my chart, where is a repeating decimal? Right there, right?
Yeah.
This is a repeating decimal. So my other repeating decimal would be in the same category, and the category is a rational number. So for number 1, you should have had the answer of rational. Number 2, what is this? First, before you figure what this one is, you have to decide, is there a square root for 64?
No. Oh,
Yeah.
Yes. What's the square root for 64?
8.
8. And then I have a negative in front of it. So I have a negative number. So I'm going to go back to my chart. And I'm going to find a negative whole number. Well, if I'm looking, oh, right there's even a negative 8. So it's right in my chart. It's in the blue, so it's an integer. And because it's an integer, it's a rational number. So you have both terms for number 2. So for number 2, you needed to write integer and rational number. If you don't have both, you need to put them in there. Do I know the square root for 17?
No.
There's not a perfect square, so that means it would be a whole number with a decimal, and it goes on forever and ever and ever. So what kind of number is that? Irrational, right? IRR. ATIONAL. Looking through your guys' homework, because remember I check it in while you're working on your bell work, I saw a lot of this. I'm just going to put in some numbers or some signs. I'm going to let you didn't show me any work. You have to show me work. You have to show me work. And the work that you have to show me is what you put in the calculator. So let's go back and let's redo these. The square root of 15 is not a perfect square, but 16 is. So what I'm going to do on my calculator is I'm going to put in, use the square root sign, square root, and it pops up 15. Gives me my answer, 3.872. I can probably stop there. And then I'm going to go back to my book. And I'm comparing 3.872 to 3.5. Now, when you compare, I need to see how you're going from place value to place value. So I need to see that you've looked at the ones placed, they're alike, so you're going to put a line through them. The next place value is the tenths, and they are different. So 8 is greater than 5. So because 8 is greater than 5, the square root of 15 is greater than 3 and 5/10. That's the work you need to show. So if you don't have it in your book right now, you better be putting it in there.
I should take zeros for some reason.
You could have put more decimals down, but you only need to go as far as the other one has. If you don't show the crossing of the numbers, that's okay, as long as you're underlining or circling the numbers that you're comparing. I need to see that you know which place value you're going to compare. So for number 5, the square root of 225, that's one of those you should have memorized. That's one of those that I should be studying, but let's say you didn't. So you're going to go to your calculator, and I'm going to hit clear all, that's this button right here, and I'm going to hit square root 2.25. Oop, I didn't get the decimal in there, so I'm going to delete it, 0.25. So what is my square root of it? 1.5. You need to write it below your problem. So I'm writing it right below it. then how do I change a percent to a decimal?
Move the,
Take your decimal.
take your decimal and move it all the way.
Wherever the decimal is, you move it 2 to the left. And so then I'll rewrite it. I can put that 0 there, but does that 0 matter? No. So both of these are now equal. I need to see that you're moving the decimal and the percent. I need to see that you've looked up and figured out what the square root of 2 and 25/100 is. So then number 6, the square root of 6 2/10. There's not a perfect square for 62, but there would be one for 64. So if I don't know it, I'm going to my calculator. I'm just doing a double click, I'm clearing all, and a square root of, what did I say it was, 6.2? Put it in there, and it shows up, 2.489. The nice thing is with your guys' paper book, you don't have to keep double clicking.
That's the same.
And then I'm gonna compare it to 2.4, and that's repeated. Okay? When I compare, my ones are the same, my tenths are the same. But I better add another 4, because it keeps repeating, and then I compare my 8 and my 4. And 8 is greater than 4.
Oh, darn it.
I got it right.
Okay? Looking at number 7. You did not have to do, you only had to do 1 through 6.
I was gonna say,
Don't
no.
worry. You guys didn't do it?
No.
No. I just want you to, we're gonna do these, keep doing these examples together. So you can write it in your book with pencil or pen, it doesn't matter at this point. But what I want you to do is watch what I'm doing and write everything down that I'm writing on the board. That's the important part. We have to order the set of the square root of 5, 220%, 2 and 25/100, and 2 and 2 to the 10th repeated from least to greatest. Verify your answer by graphing on a number line. They give us the number line off to the side. Anytime you order, anytime you compare, you have to make them the same type of numbers. What did we do with our last numbers? We made them all what? Someone said it. Decimals. So that's what we're gonna do here. We have to make these all decimals. The nice thing is that 2 of them are already in decimals. The other thing, it's easy for me to make 220% into a decimal, because all I have to do is move the decimal. So you're right, if you want, just write it right on top, it might be easier. But I don't know the square root of 5. So what do I need to use?
Our
Calculator. And I find that, I'm gonna clear all, square root of 5, 2.3606, I can stop there because I think that's as many place values as I went before. So now when we compare, we look at, the ones placed are all the same, right? Now we're gonna look at the tens place. Well, 3 of them are the same, right? 3 of them are 2, so now for the 2, I have to decide which one's the smallest. 2.2 would be like 2.20. This is 2.25, and this is like 2.22. Because that 2 repeats. So then I can compare 20 to 25 to 22. Which one is the least? 20. So when I write it on the line, I'd have to say 220%, and underneath of it, I'm just gonna put my decimal number. So that's the least. Then 2.2 repeated, which is like 2.20 is the next one. Then 2.25 is the next number. And the last number would be the square root of 5, which you write 2 and 36/100. I can stop it there. You guys understand that you had to change everything to a decimal. Using a calculator, using what we know about decimals. We're gonna skip 8 and 9. So then let's take a look at the independent practice. With the independent practice, we are naming these to which real number, all the sets of numbers to which each real number belongs. All right, so what are their names? Right here I have a fraction. Guess what I'm gonna do?
Go to your calculator.
Nope,
Oh.
go into my chart,
Oh, yeah.
because I don't have to figure out what it is. I need to know what kind of number is a fraction.
Rational.
Rational.
It's rational, because like here's a fraction right here, so I know it's gonna, and here's a fraction, it's just gonna be a rational number. So for number 1 in the independent practice, you guys need to write rational number. For number 2, does 20 have is 20 a perfect square? So do I know the square root of 20? No, because nothing times itself gives me 20. So that means it would be a whole number with a decimal that goes on and on and on and on and on. What do we call that? Irrational. Could you get that, Mrs. Clark? And then number 3, 7 and 2/10 where the 2 is repeating. If the 2 repeats, I'm gonna go back to my chart. And I'm gonna look for a repeated number. Where is a repeated number at?
Oh, rational numbers.
It's right here, right? It's a rational number. So, if I go back,
We're gonna write rational.
3 would be just a rational number. My last one is 12/4. What is really 12/4? What does it equal? 3. So you need to say what it equals.
Nicholas King, yeah, office.
So if it really equals 3,
She said just for a second.
we need to go back to our chart. Okay, the number 3. Where would the number 3 go? What color would it belong in? It'd belong in the green. So it's a natural number. If it's a natural number, it's also a whole number. If it's a whole number, it's also an integer. If it's an integer, it's also a rational number. So you have to have all 4 written down. I'll leave it up here for a second for you to get them all written down. Natural number, whole number, integer, rational.
Instead of putting number, can we do the hashtag?
Yeah.
thing?
Yeah, it's called the number sign, actually.
Number sign, yeah.
Natural what?
Yes, you can use the number sign. Or you can just say natural and then the number sign. Now we're at a different section. Now we're doing the comparing again. Can I just slap some signs up there?
No.
No, you have to show me your work. Even if you did it on your calculator, you can compare from your calculator to the paper. I need to see that you did it on your calculator and what number it is, and then what numbers you're going to compare. So on your calculators, I need you guys to find the square root of 10. Everybody needs to do it. I need to see everybody using their calculator because you have to practice using your calculator.
Oh, whoa.
I know. So I'm gonna find, what did I say that I want? The square root of 10. Okay, there's your answer. So it is 3.16, and I can really stop there. Because if I'm comparing, my ones are the same, but my tenth places are different, and 1 is less than 2. That's the work that you need to show. It's not like you're adding and subtracting a bunch of stuff, but you are showing some work. Ollie? We're on page 21. Number 6. How do I change a mixed number to a decimal.
5 times the denominator plus the whatever that's
Okay, so
called.
now we've got 31/6, but that's still not a decimal. How do I make that now a decimal? Well, how do I decimal it? You take 31 divided by 6. A fraction is always a division problem. You always consider fractions a division. So 6 goes into 31 5 times. 1 left. Add a decimal. You should be writing this down in your books. So then when it comes to a mixed number, you know how to make it a decimal. Then 6 goes into 10 1 time. 4 left, add another 0. Bring the 0 down. 6 goes into 40 6 times. 4 left over, add another 0. Bring the 0 down. 6 go into 40.
6 times.
What's gonna happen here?
It's just gonna keep
It's
going.
gonna keep repeating the 6. So comparing these two numbers, they are what? Equal. Because 5.16 repeated is the same as 5.16 repeated. Number 7, 2.21 repeated to the square root of 5.2. You need to use your calculator. You need to tell me what the square root of 5.2 is, please. Okay, 2.28, I can stop really. Because I only went 2 decimals here. The ones places are the same. The tens places are the same. So I'm comparing the 1 to the 8. And 1 is less than 8. Using the computer helps out a lot.
Yeah.
So let's look at number 8. We need to go from least to greatest. What do we need to change them all to? Decimals. How do I change 415% to a decimal? Just move the decimal. 1, 2. So it's negative 4.15. Square root of 17. Use the calculator. What is it? 4.1. There's a 3 after that. Okay, I'll stop there. Then this is just still a decimal. And this is a decimal. But notice that these are all negative numbers. If I'm dealing with negative numbers, okay, be careful. The bigger the number, the smaller it is. So I want to go with the biggest one I've got. So the 4s are all the same. The tenths, I have a 1, a 1, and a 1, and a 0. So that one's really going to be my biggest number. So if the 1s are the same, I need to go to the 10th, or the hundredths place. The hundredths here would be a 1. 5 is greater. So negative 4.15 is the smallest number, which is actually negative 415%. Then I go to the 2, which is the next biggest number, 4.123, which is actually the negative square root of 17. Then I go to 4, negative 4.1 repeated, the negative 4.08. The only thing I had to do was make sure I changed everything to decimals and then ordered them. Yes? Oh, you'll have to wait just a minute.
They put it in the answer.
Yeah, it's pretty much in the same order, isn't it?
Yeah.
We just had to change them. They're not always gonna be that way. Number 9,
Whoa.
we have the square root of 5, the square root of 6, 2.5, 2.55, and 7/3. What's the square root of 5? It can't be 6 point. Everyone it needs to do is,
2.23.
2.23, that's probably far enough. Square root of 6, Caleb, what is it? Do it on your calculator. Kat, what do you have for the square root of 6? Oops, say it louder, babe.
2.449.
Okay, we can probably stop there. Then we have the 2.5, 2.55. How do I change 7/3 to a decimal?
Divide it.
Divide it. Show me the division. 7 divided by 3. 3 goes into 7 twice. 1 left, so I have 2 and 1/3. But I don't want a fraction or a fraction. Hello? Add a 0. Bring the 0 down. 3 goes into 10 3 times. 1 left. Add a 0. Yeah, there we go. It's gonna repeat. Now we're just dealing with positive numbers, so you just go smallest to greatest. 2's are all the same, so cross those off. The tens places are different, so I got a 2, a 4, a 5, a 5, and a 3. Well, the 2's gonna come first, which is the square root of 5. Then the 3 is gonna come next, which is 7/3. Then 4 is gonna come next, which is the square root of 6. Now, which one do I go next? 2.5 or 2.55? 2.5, because that's like saying that there's a 0 there. So 2.5, and then 2.55. Okay, so in order to compare the numbers, you have to make sure that they're all decimals. Before we go to our extra practice, for you guys to have practice, I want to show you something on your calc. Well, go ahead and turn to page 23 and look at number 27. Turn to page 23 and look at 27. Do you see that that's a 6 1/3? I can figure that out. 18 plus 1 is 19/3. So I take 19 divided by 3. 3 goes into 19 how many times?
6.
Which is
18.
18, 1 left. And what's gonna keep happening here? It's gonna keep repeating. So I know 6 1/3 is 6.3 repeated. I don't know the cube root of 240. But I have a calculator. Watch how you do it on this calculator. And this is the reason why you want this calculator, not the graphing calculator. Do you see this sign right here? I know I can't. There, it's kind of, maybe you can see a little bit better now. Yeah, I gotta keep that 6.3. What you'll do is you'll hit this button. So we have the square root button, and then this button here is to the end. That would mean I put my number 3 there for that it's being cubed. Then I hit right down here, and it's the cube root of 240. So I type in 240. And it gives me the answer, 6.214. Now, I can compare those two numbers. The 3 is greater than a 2, so 6 1/3 is greater than the cube root of 240. Okay? Tanner, you can go ahead. Your classroom